Hi everyone, and welcome to my talk. Today I'm going to talk about the hidden cost of relying on AI tools. Now I think from my experience we can avoid copy paste and then eventually regret. So to understand better my point of view, I'm going to talk about my path and my experience in the last recent years. So I started as a backend developer prior AI tools explosion. After a few years, the AI tools began to be popular, and during this time, I started managing people, developers, managed developers from senior to experienced and juniors. And in the last recent year, I came back to my position as a backend developer, and this is where I'm going to focus. So I'd like to introduce myself formally. So hello, I'm Nofar Diamant. I'm a senior backend developer at AppsFlyer. I used to manage other developers. In my spare time, I like to volunteer in women organizations and to mentor other women. And as I said, I used to write code before the chats told us how to do that. And as you can see, I like writing code with my dog. So before we go deep into the experience I had, I would like to give you a general background on the world and the context that we're living in. So as I said, I'm working at AppsFlyer. So what do AppsFlyer do? So AppsFlyer is basically a platform for marketing analytics dashboards. We are talking about our clients, our marketeers, and we are enabling them app attribution and viewing the ROI, basically powered by massive scale event data that we process. As you can see, we provide dashboard that enables them to have better campaigns decisions in the future. They can see the active users that they have in their app, the total revenue, and the cost that they are paying for their campaigns. And each of this data that you can see here is data that is basically streamed into our system. So part of our backend work is basically guard our resources and keep our resources at scale. So in order to do that, part of what we do is by using a cardinality mechanism. For those of you who don't know, cardinality is the number of distinct values a field can take. So as I said, we are working with applications. For example, each application we want to limit the number of distinct values each application has. So in order to do that, we developed a mechanism which is called graylist. Graylist is basically a cardinality map where only the keys that exceed the limit are stored. For example, if we are talking about an app ID, then we want a specific app ID to have the top 1000 values. So we will limit a specific app ID to have 1000 values. So for example, if we have a specific app ID that exceeded the limit of 1000, then we will store this app ID in our system. And then we will take the 1000 top limit, for example, of a campaign ID that this app ID has, and we will store the campaign IDs that are whitelisted in this app ID. Those campaign IDs will show up in the dashboard. So as I said, I'm going to share my experience. So I'm going to share my experience through the first task I had in the team. So the first task I had in the team was to adjust the current cardinality to have a different number of threshold of cardinality to be shown in the dashboard. So just to give a quick recap, our cardinality mechanism is set to all our clients to enable the top 1000 values for each dimension. we want to adjust it to enable a higher number of values per application. Why do you want to do that? Because we have a big strategic client that is asking for a higher number to appear in the dashboard, and we want to do that with adjusting the current cardinality mechanism with the help of Cursor. So just to overview our current architecture. So we have the cardinality config, which is an object config that contains a sequence of fields. A field is the different dimensions. We want this config to be reused for other jobs. I didn't say that. We are talking about a world of Spark, distributed jobs that are dealing with this big scale of data. Inside the config, we have the sequences of the fields. Each field is the dimensions. Each field contains the property of an attribute, which can be app ID, campaign ID, the different attributes, and each field has a threshold. We want, for example, campaigns to have the top 1,000 values, but for I don't know, campaign names, we want the top 5,000. It doesn't make any sense, but just for the example, we have the class of the processor, which load each field from the data and then initiate the create gray list method. And then we have the gray list creation initialized, and the output of this method eventually is the gray list data frame, the map that we are using in the process. So when starting to work on this task, I wanted to use Cursor. So the first experience I had, the first ping pong I have with Cursor is this one. So I wanted it to not make any code changes. I want to have a custom threshold to the fields based on an app ID var. How do you suggest to do that? So the first suggestion from Cursor was to have inside the field object function based on the app ID to decide on the threshold, and another map that contains the app IDs and the various attributes and their thresholds. I didn't say that. Each attribute has a different threshold. So the new special threshold was intended only for the unmasked media source attribute. I didn't like this suggestion, and also the gaps that I identified is that it didn't work well with the real flow of the system, of their architecture, and I needed a solution that would align with the processor and the gray list architecture that already existed. So I came back to the Cursor and I wanted to refine my prompt. So I wrote this. I want to define where to use the special threshold based on list of apps, where in the cardinality processor, which is where I wanted the code to exist. Should I change the code? Check which app I am currently dealing, and based on that, use the special threshold. So the cursor suggested this solution. As you can see, it suggested collect, and also to distinguish if the data frame contains a special app, and if so, use the special threshold. I didn't like this solution, first of all, because collect is, I know it's a risky solution at scale. It uses the driver, it collects the data to the driver, and I didn't want to do that. And also, it didn't work well with the solution that I know that it wasn't correct. Why? Because one batch can contain a VIP and a non-VIP apps inside the one batch, which means that a single threshold for a batch is not correct. It's not a correct solution. So I came back to the cursor again, and I wanted to have a correct and better solution. So I told him, we're dealing with lots of data. Is it good practice to use collect? Because I remember that no. Also, it may appear that in one batch I will have a special app and no special app. How do you recommend dealing with it? So the cursor suggested this solution. It suggested to split the VIP versus non-VIP to two different data frames and handle them differently. It was a better solution, but again, I didn't like it uh, at all because I wanted the threshold decision to live in a config and not inside one processor. As I said, I want this solution to be reused and the logic to not be centralized in one job.
A few moments later.
A few ping pongs later, we did it together. So we came up with a solution that was reusable. Now the config owns the VIP apps list and a per field threshold strategy. We came up with a scalable solution. Now each field carries an optional and a safe UDF wiring, which is also avoiding a driver collection. And because we are now we now have an optional threshold UDF, if the field doesn't contain this UDF, then we are going back to the same behavior as today, which is the static threshold. So now we have a new structure. We have the same cardinality config, but now the field contains, some of the fields contains UDF factory and the VIP apps list. Inside the field object, we have the now two thresholds, the default one and the new one, which is optional. And we have the UDF factory, which is also optional. And of course, the processor class, which is now dealing with observing if the UDF has this, sorry, if the field has this UDF optional, and besides that, nothing changed. And inside the gray list creation, we are observing if the UDF exists, and if not, then we want to the static threshold as we did before. So my main conclusions from this experience, I'm dividing it into two. The first set of conclusions is how I want now to develop with AI is, first of all, be clear, clarify the scope and the requirements. I don't want to be ambiguity because ambiguity is the first number one source of wasted iterations. So just be as clear as you can be. Clarify the scope and the requirements from the beginning. The second thing is critique reading. Treat the suggestions as hypotheses. Don't take any suggestion as the truth, and look for hidden assumptions and challenge them. By challenge, I mean ask questions. If you think something is not correct, then ask it, ask for clarifications, and ask for alternative ways to do the same thing. And of course, use tests, and use these tests not only as a safety net, but also as a communication tool. This can clarify the chat or the other tool, what is the expected flow that should happen. And the second set of conclusion is how we want to deal with AI when managing developers and specifically juniors. So the number one thing is problem framing. Juniors tend to jump to implementations. So you as manager should coach them to frame, first of all, the requirement scope and be as clear as you can be. Again, reading, normalize the mindset that suggestions are drafts and are not the final solution. Incremental refine, first do it step by step, first get it correct, then remove the scalability issues, and then generalize it for reuse. That way you can reach an optimized solution step by step. And the last thing is a good engineering communication. Don't be afraid to ask the juniors questions and give them you can give them a structure of what do we want to change, what we don't want to change, why we are using this approach, and also the most important thing, how we can validate that our solution is the best one and is, of course, a correct one. And that's it. Thank you. And thank the AI and have better decisions and solutions in the future. Thank you.